To start off the video, firstly, the formula I have input is x squared plus b multiplied by x plus c. X squared being b12, b being the absolute cell f4, and x being a12, and c being the absolute cell h4. The y values are all here, starting from 4, -2, -6, -8, and so on. Secondly, here are the graphs of the two equations. Y equal x squared is represented by the blue, and y equals x squared plus bx plus c is represented by the orange. To achieve this graph, I selected the table columns, insert, scatter chart here, and I just labeled them accordingly. Thirdly, the discriminant. The formula is b squared minus 4ac. Using this formula, I achieved the discriminant of 33, which is a positive number, giving the two solutions in x1 and x2. Referring to the completed square form, y equals x plus b over 2 square plus c minus b square over 4. For the horizontal axis, if b is more than 0, the graph will shift to the left. For example, I'll change b to 7, and the graph will shift to the left. If b is less than 0, the graph will shift to the right. I'll change b to -5, and the graph shifts to the right. For the vertical axis, similarly to the horizontal axis, if c is increased, the graph will shift up. For example, I change this to 9, the graph will shift up. If decreased, the graph will shift down. So for another example, I'll give you -13, and the graph will shift down here. So therefore, when value BC is increased or decreased, the graph will shift left, right, up, down respectively. When b equals to 3 and c equals to -6 and discriminant is positive, there is two different solutions. For example, switching to different numbers, b equals to -7 and c equals to 9. See, now there is also a positive discriminant and two solutions which are also positive. Therefore, when the discriminant is greater than 0, there are two different solutions. The y values have now changed, and the discriminant is now equal to 0, and solutions are both the same. Let's try with another pair of numbers where b equals to -8 and c equals to 16. As you can see, the discriminant is also 0 and the solutions are also the same. So therefore, when our discriminant is equal to 0, there is only one real solution. Changing the y values again, b equals to -7 and c equals to 13. The discriminant is now a negative number and the orange line is above the x-axis. Also, there are no solutions. Trying again with different numbers will give the same results. So let's change b to -5 and c to 7. See? Negative discriminant number, orange line above x-axis, and no real solutions. Therefore, when discriminant is less than 0, there are no real solutions.